Hello everybody, and welcome back. In this video, we are going to be looking at polygons. So you need memory piece number 43, I believe. Yes, item 43. And we're going to put this on a page by itself. So if you want to go ahead and find a blank page, I would not glue this down yet. I don't want you to stick it down until we're ready. A polygon. You've got a flashcard for this, but let's just define it right here on the top of this page, just so you know what the definition is, and we're working with the same information. I'm sorry, I'm bumbling this morning. A polygon is a shape. Let's just use the proper definition. A plane figure, and plane means that it's flat, it's two-dimensional, with at least three straight sides. So a circle cannot be a polygon. And three angles. That's the simplest polygon. Three sides, three angles, and the sides must be line segments. They cannot be curved to be a polygon. So this memory piece is going to help you identify polygons. I've given you different examples of polygons, and we're going to go in and tell the facts, the information about the polygons. If you have watched the assembly video already, which you should have, you've already prepped this piece and it's ready to go. So I'm not going to go over that in this video. I want you to open the triangle door. So we're looking here at this triangle. Your triangle is open to the left, the door is open, and here are the facts about a triangle that you need to know. So triangle has three sides and three angles. Tri, means three. So triangles have three sides, three angles. Any triangle's angles add up to 180 degrees. And we're going to be using that fact in one of our problems, one of our examples. This is very important that you know that the angles add up to 180. Triangles can be named by side. And there are three kinds of triangles. There is an isosceles triangle. And an isosceles triangle has two equal sides. A scalene triangle has no equal sides. And then an equilateral triangle. Equa means equal. Lateral is side, so that one gives you a clue. Equilateral is equal sides. Has three equal sides. So you can name your triangle by its sides. You can also name your triangle by its angles. An acute triangle, that's what we're looking at here in the green. It has angles that are all less than 90 degrees. A right triangle has one 90-degree angle, and then the other two angles would be acute. Let's go ahead and put that in. It won't hurt a thing. Two acute angles. And then the obtuse triangle has one obtuse angle and two acute angles. My hand's cramping. This is a lot of information, but it's important. I would keep this notebook. If you go to college, you're going to need to know these. Your flashcards also. Practice using those vocabulary terms, and you will develop a math language. That is so important. Okay, let's move to the other side here. Let's just go this way. So open this door, and you're looking at this square. And let's name it. I want you to know how to spell them. A square is in the quadrilateral family. Quad means four, lateral means side. So a quadrilateral is a four-sided polygon. Quadrilateral. A square has four right angles, and so it totals 4 times 90 is 360, just like a circle. A square has two sets of parallel lines. Let's say, first of all sides are equal. Two sets of parallel lines. And we indicate that with tick marks. So I'm showing that this side, that's too big, sorry. This side and this side are equal. This side and this side are equal. All sides are equal. So let's go back to our first example and mark this one. I believe this is isosceles, just barely. So that means that this side and this side are equal, and that these angles down here are equal. Okay, this is an isosceles triangle. It's also an acute triangle because all the angles are less than 90. Okay, so these tick marks on the sides are showing congruence. They're showing the sides that are equal. Okay, so two sets of parallel lines. I think that's all for the square. Let's mark those 90-degree angles in there, just so that you know those are all 90 degrees. 4 90s make 360. So it has a total of 360 degrees. Okay, let's look at the rectangle. That's this one. So open this door for rectangle, and let's write some facts about our rectangle. Okay, the rectangle is a quadrilateral. Quad means 4, lateral means side. Quadrilateral is a 4-sided shape. It's in the quadrilateral family. It has 4 right angles. It has 2 sets of parallel lines. It has width that is parallel. And then it has length that is parallel. Now, watch what I do here. I can't say that because all of those are not equal, so I'm going to say that this side is equal to this side. That's all that means. It looks funny. It's just telling me how to match up my sides. I want you to compare this picture to the square. The definition is almost the same, except that a square has all equal sides. So a square is a special kind of rectangle. It is a very specific type of rectangle. Okay, one more thing here. I want you to mark your 90-degree angles. I think that's always a good idea. If you have 90 degrees or you want to show 90 degrees, use those boxes. So it is a total of 360 degrees. As quadrilaterals will be. Triangles total 180. Quads will total 360. Okay, this next one is my favorite. This one is called a trapezoid. It's like it was a triangle at one time and it got caught in a trap. A piece is chopped off, lopped off. A trapezoid. A trapezoid is a quadrilateral. Because it has 4 sides. A quadrilateral has 1 set of parallel lines. And in this case, they would be here and here. We call those the bases of the quadrilateral or the trapezoid. Let's put it right here. You have this base and this base. Because you could stand this quadrilateral on either of those bases and it would stand up. So those 1 set of parallel lines are called the bases. Okay. And the quadrilateral, the angles will total 360 degrees. In this particular one, you have an obtuse angle right here. And you have an obtuse angle right here. And then you have a cute little angle down here, less than 90, and an acute angle right here. So in this particular quadrilateral trapezoid, you have 2 obtuse angles and 2 acute angles. That won't always be the case. Sometimes you can have a right angle, but this one they will add up to 360. Okay, one other thing about the quadrilateral. If you need to find its height, and I'm going to have to erase, you don't have to erase if you don't want to, but if you need the height of your quadrilateral, you always want to look right here. Let me do this with a straight. Height is from here down to here. You always want to measure height at a 90-degree angle. That is so important, because think about when you go to the doctor and they measure your height. They don't want you leaning to do that. They want you standing straight. So the height is an imaginary line, but it is that distance right there. Okay. So much information to show you here. All right, this next one is called a parallelogram. 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 It looks a little bit like the state of Tennessee. If you think about it, Tennessee is a funny shaped state. It's long and narrow, but I always thought of that when I looked at a parallelogram. So let's figure out, is a parallelogram a quadrilateral? Well, yes, it is, because we have four sides. We have this side that's equal to this one, and then we have this side that is equal to this one. The height of the parallelogram, just like with the trapezoid, you would always want to measure this way. So this would be the height. Sorry, my pen is too thick, or it's not thick enough. And so the height, this is called the base. This is also called the base. And that's sort of the anatomy of a parallelogram. So let's take a look at this in detail. It is a quadrilateral because it has four sides. We can see that it does have two parallel bases. And they're equal. That's indicated by those tick marks. And then it has two parallel sides as well. I'm going to call that the width. And I'll label those for you on the diagram. That would be this one is parallel to this one. But do not confuse the width with the height. That is so very important. And because it is a quadrilateral, it has a total of 360 degrees. When I was teaching every day, my students had trouble with this one sometimes. I taught adult students, so I always told them that a parallelogram is like a drunk rectangle. I would not tell that to children, but these were adults, and the parallelogram is not straight. It's not standing straight. It has no right angles, as opposed to the rectangle, which is standing straight and tall. The parallelogram is leaning. So we called that one, just slangily, we call that the drunk rectangle. But I would not say that. I would not tell children to use that analogy. Okay, rhombus. This is a special kind of parallelogram. It's like a square is a special kind of rectangle. A rhombus, and that's a funny word. It has a funny spelling. A lot of these geometry terms have Greek origins because the Greeks were very, very proficient with geometry. So a lot of these words that look funny come from the Greek language. They look funny to us, but if we lived in Greece, they would not be so foreign. A rhombus is a quadrilateral. It is a parallelogram. It fits the definition of a parallelogram. But here's the thing that makes it special. It has parallel bases. So the base sides are parallel. They're also equal. But check this out. So are these. So the wide sides, we don't call them bases, we call them the width, but they're equal. And that's what those tick marks are showing me, that all sides are equal. So we can say that all sides are equal. I knew there was something with the parallelogram that I forgot to do, so we'll have to go back. It totals 360 degrees. But there are 2 acute angles. Those are acute little angles. 2 acute angles, because remember, it's leaning. It's like a drunk square. And then 2 obtuse angles. It's not that perfect 90 that makes it straight up and down. It's leaning. 2 obtuse angles. That total 360. Okay, let me go back and label that on the parallelogram as well. I knew there was something I was forgetting. 2 acute and 2 obtuse. You can't have right and be leaning. So here's the acute that matches up with this acute. And here's the obtuse that matches up with this obtuse. Total of 360. That is true for your quadrilaterals. Okay, we are almost there, guys. This is a pentagon. It has 5 sides. So let me ask you something. If it has 5 sides, how many angles does it have? Think about that a minute. A triangle, let's go back through here. A triangle has 3 sides and 3 angles. A quadrilateral has 4 sides and 4 angles. So if a pentagon has 5 sides, how many angles does it have? Well, it has 5. So anything that is 5 sides and 5 angles is a pentagon. And I'm not going to go into this one any further. I just wanted you to see the pentagon and know that it has 5 sides and 5 angles. Okay, so how about a hexagon? Hex has the letter X in it, just like the number 6. 6 hex. Hexagon has 6 sides. So how many angles will a hexagon have? 6 angles, 6 sides. I skipped the 7. I'm going to tell you what that's called in just a minute. But I wanted to show you a stop sign because this is a very common one. This is called an octagon. Octa means 8. Think of an octopus that has 8 tentacles. If you play the piano or play music, you know that an octave has 8 notes. Octagon has 8 sides. And 8 angles. Now, I did not show you a picture, but I want to at least give you the names. A heptagon, and I'm putting that one in this area right here. H-E-P-T-A, hepta, heptagon, has 7 sides and 7 angles. We did octagon. A nonagon, nona is 9 sides and angles. And a decagon is 10. And they carry on from here. But I just wanted to give you the first 10 of them, because those are the ones that you're going to encounter most often. These you will not see very often, so I didn't draw them. I was running out of room. Okay, in this last square, there's something else that you need to know. You need to know that a regular polygon has all equal sides. An irregular polygon all sides are not equal. You may have one that's out of whack, or all of them may be not equal, but at least one of them is not the same as the others. So let's go back to our pentagon for just a minute. And suppose they ask me on a test, is this a regular polygon? Well, it's very hard for me to tell without measuring. It looks to me like it's probably not a regular polygon, but it was supposed to be. So here's how you can tell. You don't want to just eyeball things if you can help it. But if they give you these marks, and all of those marks match, this particular pentagon is regular. All pentagons will not be regular. Some of them will be irregular, but this one is regular. The hexagon. Suppose they give me a hexagon that has these markings on it. Is it regular? Yes. This is called a regular hexagon. Here is an octagon. Stop sign is a regular octagon. What I'm trying to get across to you here is the importance of these marks, because they are telling you about regularity. This is a regular octagon. Let me ask you this. Is this a regular quadrilateral? No, because the marks don't match up. That is irregular. Is this a regular quadrilateral? Yes, because all sides are equal. Regular? No. This one, we have equality here and here, but that's not always the case with trapezoids. Trapezoids can be very weird shapes. That's why I love them. If I were a shape, I would be a trapezoid because I'm kind of weird. I like strange things. I'm just a mixed up person in some ways, but I'm happy. So trapezoids can be anything. They can be all different kinds of things. All right, a square. Is a square a regular polygon? Yes, it is. Is this particular triangle regular? No, because the bottom of this triangle is different than the sides. Okay, and by the way, this bottom is called a base. The height of the triangle would be measured down this way. You never want to measure the height of a triangle by its side. You need to measure its height from its vertex down to its base. It's always a 90-degree measurement, never the side. Okay, so that's just to help. Oh, here's one more. Sorry. Is that regular? No, the sides are not all equal. Okay, just practicing vocabulary in this one. We have done no math. We just looked at vocabulary, and that is so incredibly important. Okay, the last thing I want you to do is to glue down your piece. And before you glue it, watch what I'm doing here. I'm going to resize mine so I can fit just a little bit more in here. You turn this piece over. You're going to put the glue on the back, and you glue only this portion down. You don't want to stick the doors down because you want them to close. So put glue where I've got the red part on the back of that. Stick this down to your book. And then close the doors. And we're going to label the outside doors. So the outside of this door, let me put the front of doors. What is this green shape called? A triangle. So when you come back to quiz yourself and the door's closed, I want you to think of as many facts about triangles as you can before you open up that door. This blue one is called a rectangle. Rectangle. And one other thing that I want you to know, this is another one of my pet peeves. The two words that I'm about to write, I want you to know the difference. The first one is angel. Angel. The second one is angle. Okay? This is a soft G. It has the J sound. This is a hard G. It has the G sound. Be careful with that spelling. I don't want you to go into college and write this one. This is not an angle. This is an angle. Okay, so lots of people misspell those words, and I don't want you to be one of them. Okay, down here, what's this orange one called? On the outside of the door is parallelogram. So you write the word parallel, O-gram, parallelogram. 5 sides, that's a pentagon. 8 sides is an octagon. Okay. This yellow one is called a square. It's also a quadrilateral, but its formal name is a square. This guy, my favorite, is a trapezoid. This drunk square is a rhombus. Rhombus. 6 sides, that's a hexagon. And then down here, let's list the prefixes. Hepta, nona, and deca. And then we also talked about regular and irregular. So you've got this glued down. Close all your doors, and you should see these titles on the fronts of those doors. I want you to practice these often. That's why I didn't just have you copy this into a notebook. I want you to think about what's under that door before you open it up, so that you're making your brain retain this information. You won't have this on a test, but you can put this information in your head before the test. If it's in a memory piece, you need to memorize it. So this one was quite a piece. This is one of the most complicated ones I think we've done. But this is your polygon family. And hopefully you have enjoyed this one. There was no calculation. I didn't need a calculator at all. But it is heavy on the vocabulary. Keep practicing those flashcards. Build that math language so that you can speak that as well as you speak English or Spanish or whatever language you speak well. Okay, I'll see you in the next video, and I hope you have a wonderful day. Bye-bye.